Okay, that was Crossroads, I think, finishing up there with Stevie Ray Vaughan. Okay, if I looked at the list on the CD correctly. And we are at Crossroads. We have a test coming up, just to remind you. In reflecting this morning, grading papers for the last couple hours, and reflecting on what we have to do before we take the test, there are 2 labs that need to be done, and I need to take time to talk about the box plots today. Yesterday I tried to set up for you the general ideas involved with bivariate data analysis, and you should be able to make major headway into the chapter 4. I think 4 is on regression line. Is that right? Or do I have them backwards on 4 and 5? Which? You have 5 on regression and 4 in correlation. Then you could be doing chapter 5 on the regression line. I would like to talk about correlation today and what it means by looking at the same data set that we entered yesterday and to try to put that together. And as I say, take time to look at the box plot. Now the lab in the box plot just replicates what we did in class finding fences. Okay? And you simply have 2 box plots that you can look at simultaneously. One for life expectancy female, one for life expectancy male. And you are expected to type out the formulas that are on page 5-4 of your lab manual. Those are the formulas we've been talking about. And essentially, you're trying to determine if there are countries with birth rate, not birth rates, but with life expectancy for females that would be considered unusual. It's going to go without saying that if we have life expectancies down in the 30s, that should be considered rather unusual. And we have some really low life expectancies at this point in the world. And many of those are in Africa, where HIV, drought, genocide have just really had an impact on life expectancies, and we're approaching the low 30s. So in those countries, the idea of having a midlife crisis doesn't make any sense. I guess you'd have to have one of about 15 as you're going from adolescence into adulthood and expect to live maybe only until 32, 33 years of age. So it's a very different world in terms of life expectancies. So as we think of the box plot with suspicious points shown by little boxes, I'm going to ask you to identify those countries and comment on what's taking place. You're going to find more suspicious values for women than for men. And it's related to what you already discovered as you looked at life expectancies, male and female, earlier, where you observed, as we just looked at those, and this again depended on which row you were seated in, because I asked you to analyze different variables. But for those of you who focused on life expectancies, you noted that women tended to live 5 to 7 years longer than men. So if you have 5 to 7 years as an average value higher for women, so let's say women are going to have a life expectancy in their 70s, mid-70s on the average, where men may have mid-60s, if the low for both of them is at around 32, then you're much further from the middle with women than you are with men. So if you think of the distance from the median to the low value, it'll be greater for women than it will be for men, and that is tied together with the concept of offense. And so you're going to find many more countries with suspicious values for women than you do men. And that's going to be the part in the write-up that's going to give you a little bit of a challenge. Before we go to that, I'd like to continue with our work from yesterday. You have your data in your calculator. You have your 6 pieces of data, correct? And I'd like to give some meaning as to what it is involved when we say that a relationship is stronger or weaker. To do that, we need to get some values from your calculator, as I illustrated yesterday, when we went ahead and used that y prime key. So the y prime key, and I need to again get some kind of background here that allows us to see the calculator nicely. Bring this down a little bit tighter, and I'm going to turn it on. And right there we seem to be getting some pretty good light. Let's try cutting to the camera. This is stat 1. Remember, we had our data values in here. And as I slide this up, and I'm going to drop the camera down itself, remember there was a y prime key down here, and I'll try to go ahead and tighten up that focus a little bit. You see the y prime key that is involved with closed parentheses. Now we're going to call that y hat. To get the value for y hat, I have to input my data. And we're going to do that for each data value. So we had 6 data values. And as I slide this down and go back to the document cam, my first data value, I believe, was this 1703 and 7549. So will you go ahead and put in 1703 in your calculator, assuming your data is still there? If not, then we're in trouble. But if you have your data there, you're going to input 1703, and then you're going to hit that gold y prime key. So I'm doing that for you as I slide this back up. There's my 1703, and I'm going to hit what in reality looks like an orange key in my calculator, and hit the y primed, and I'm getting 7648. So I'm going to slide this back down, and I'm going to write in next to this 7648. So let's come off there for a moment, Jennifer. 7648. We need that for each of our values, and we're going to call this y hat. Y, of course, was our other value, so you have something like, let's bring the camera up just a little bit, see if I can get it to hold position, focus. We have something like this. So you have a y and a y hat. Do we concur in that value, for those of you who have the data in your calculator? Well, you now do that for the next values. So you put in 1071, and if you'll do that, I'll write down the values as you share them with me. So the 10.71, what is your y hat? 10.71, then the gold and the y primed key. Daniel, do you have it? 82.08 is their confirmation. Anybody confirm that? 1 confirmation, 2, good. Okay, let's go to 7.87. 84.6, Juan says. Is there a confirmation in that? Confirmation time. Yes, I'm getting head bobs. Okay, now we're going to go to a 2112. I need the estimate there. Anybody? 2112, gold y prime. 7285, going down to, again, head bobs? 7285, okay, a couple head bobs. 2195. 72.1. We only have one more to go. That's 20.92. Anybody? 20.92 gold y primed. Waiting. 73.03. Do we agree? No, is it 036 you said? So we'd round off to 7304 then, correct? So we're going to round off to hundredths, and this is a little bit sloppy from the standpoint of round off. Do I have my other values okay with round off? Do we agree? Now, what we need to do, so we're going to slide back up here to the top. I want a new column, and it's going to be y minus y hat. So I'm going to put up here y minus y hat. I just need the difference of those two values. So what do I have for the first one? It's going to be a negative something. What is it going to give me? A negative 101? No, wrong way, my error. Is it a negative 0.99? What is your value when you subtract? 7549 minus 7648. Negative 0.99, agreed? So we're just doing a subtraction. So I have an 80.59, and I'm subtracting 8208. That again will be a negative. What is my number? Negative 1 point what? 49? Thank you. Then I have, the next one is 8559, subtract 84.6. That's going to be very close to a positive 1. What do you get? Point what? 99. Now note, just in passing, that here I have a negative 0.99 and a positive 0.99. That would go to 0 if I just added them up, correct? One of the things we're going to note as we come down here, that the sum of these errors will be 0, except for round-off problems. So you might get 0.001 or negative 0.01, but theoretically, we should get a 0. Okay, continuing, coming down. 4.7, thank you. And that's a positive, correct? Next, we have a 65.27 minus a 72.1. What is your difference here? A negative what? Folks, this is just put the numbers in your calculator and get an answer. Quickly. I'm waiting. Negative 6.85. Just one more to go. This one will be a positive. And it looks like it's going to be a 361. Do we agree? Now there, let's see if I can, I'm going to have to bring the camera up just a little bit. I'd like to get the, and as Jennifer can see, you can't. I have a very determined camera to do what I'm not wanting it to do. Okay, let's try. There are my residuals. So you can see on the screen the residuals. Now what I want is the summation of these residuals, which is the summation of E. E stands for the error or the residual. Will you add those up? Now the argument is we should get what? We should get a 0 for that. What are you getting? I have them on the screen so you can put them into your calculator and add. I would add the positives, add the negatives, and then take your difference of the two. What are we getting? I'm waiting. Not very patiently, but I'm waiting. Anybody? What? You got 0, 0? Exactly 0. Neither positive nor negative, just 0. It can't be negative 0.0. It's just 0 then, right? Yeah. Okay. We could say negative 0, but we usually don't. Did we meet our condition that we said must happen? And the answer is yes. Okay? But that's not what I really want. So back to the list. Now I need to square all these errors. So I want E squared. So this is y minus y hat quantity squared. Okay, so you simply are going to square each of these entries. Now this is going to be close to 1 here. This is close to 2.25, close to 1, and so on. So we can make some pretty good estimates, but I need some actual answers. So as you square those values, share them with me, please. The first entry squared, which is negative 0.99. What do you get? 9801? Okay, we'll carry this out 4 digits. Next one should be very close to 2.24. What do you get? 2401. This is again going to be a 0.9801. 4.7 is going to be about, let's see, 4, 5 would be 22.5, so my guess is about 21, somewhere in there. What do we get for 4.7 squared? 2209, I was off by a bit. Okay, the negative 6.85. What do we get there? It's going to be close to 48, 49. What do we get? 46.92. And the 3.61, going to be more than 10, close to 12, 13 nearly. What do you get? What is it? 1303. Do we agree? I want a new total, the summation of the E squareds.
Okay, for the second one?
Yes.
It's 2.2201. Sorry about
2201.
that. Yeah, sorry about that.
That's okay. We'll just make it a fancy 2. So that's 2.201, 2.22. Looks pretty bad, but we'll try to remember what that represents. Now, it ends up that we, on the last 3, only went to the hundredths. So there's some digits we can throw in there that would help here. So instead of 2209, what were the next 2 digits? When you squared 4.7, or was it 7.6 after the 0.09? 4.7 squared. Whoa, I have a 2209. Have I misentered that? On the 4.7 squared? It's just 09 and stops? Okay, so I'll put 2 zeros here just to clarify that. What about the 6.85? Okay, so there's a 5 after the 9.2? So 9225? Okay, thank you, Nick. Then the 3.61, what are your next 2 digits after there? So a 130321, do we agree? Okay, now I need to have all those added up, so if you will be kind enough to do that, we will get the summation of the E squareds. Does anybody have that? I know those of you watching from home probably tired of seeing a bunch of numbers on the screen. Turn up the volume. We'll try to entertain you with some vocabulary as we go along. Okay. Summation of the E squares. This is summation of your residual squares. Do we have a number? Anybody brave enough to give me your value? If not, check with the neighbor and see if you agree. 8422? 8422 sounds a bit high to me, but maybe not. That's 30. That makes sense. 84.22. Any digits after that? 49. Anybody confirm this value? Now that I've written it down in ink. Anybody? Folks, we have enough people with a calculator in here that you should be able to give me at least one head bob in this. Okay, I have 2 people in agreement. Room full of calculators, and I only have 2 people in agreement. By the way, this is, in essence, what we're doing here is a test question. A week and a half hence. Does anybody else agree? I'm up to 3 agreements now. Folks, this is just adding 6 numbers. You could do it longhand at this point and have checked your work. Okay, let's put it back up there. 84.2249. Do we concur? I got about 4 people agreement. That's as much as I'm willing to be patient to get. Okay, I need another value out of here, so we're going to slide over just a bit to my y values. Now, using your calculator, and just a reminder, coming off there for a moment, in the calculator, and I'm going to regret doing this in a moment because I will now have to try to bring the camera back up so you can see what I want. Okay, I'm getting down here. I would like to know what the standard deviation of y is. So let's look at the calculator. Do you see the S sub y right above the 8 key in green? That's S sub y. So if I hit the recall and S sub y, I should get the standard deviation if I turn on the calculator. So sorry about that, and I am not getting any. Let's see what I can do to get some lighting that is good. Let's try that. Okay, I'm going to try doing that recall S sub y again. And I'm getting 6.7366. So a 673.66. Okay, come off there for just a moment, Jennifer, so I can write that down. And then, finally, we're in a position to say something about what we're trying to do. So this is the standard deviation I have. I need one more thing, and that is give me the variance. So this is s squared sub y that I want now, the variance of y. And what do we get there? Squaring that. $45.38. Need another two digits. What? 1.5. Thank you. Any confirmation in that? Okay. Now, what are we going to do with all that? That's the question. We are trying to explain the value of y by knowing x. I'm trying to predict something. We are arguing that x, and listen to my language here, is the explanatory variable. If you know birth rate, you should be able to predict life expectancy. That was our argument all the way back to week 1. I have an equation that we tried to do yesterday, and I did not write that down on this piece of paper. Will somebody share that value? And I can turn the calculator back on and get it, but let's just take the equation for y hat. It was a negative, was it about point, what is it, negative 0.89. So negative 0.89x, and it was about plus 92? 91.57. Okay, this was my equation, and so the argument is that if I take that equation and I put x into it, I can get an estimate for y. That's what we just did with the calculator when I put in x and hit gold y prime. I was substituting into that equation. If the relationship between x and y is linear, then every point should be in that line. And every value of e should be 0 in a perfect world. Now, we saw yesterday that the line we drew had some points that would not be in the line no matter how we drew it. The further points are away from the line, the worse the model we create. The closer the points are to the line, the better the model we create. A measure of closeness is this value of y minus y hat. Now, the argument is that we do not always get the same value of y because there's a relationship between x and y. If you got the same value of y, no matter what the birth rate is, we would have a horizontal line. If the birth rate is 70 years of age everywhere in the world, no matter what, I didn't say that right, I blew it again. If the life expectancy is 70 everywhere in the world, no matter what the birth rate, there's no variability in y. Now, we're arguing that there is a natural variability in y because of the change in birth rate. S squared sub y gives me a measure of that variability. We call it the variance. So I'm now going to go to the board and write some numbers up there. I'm going to take the s squared sub y, and I'm going to write it as what I have that I'm reading from my view of the document cam. That's 45.3815. Okay. Now, in particular, I want to remind you what s squared sub y represents? We know it's the variance, but s squared sub y is the summation of the y minus the y bar quantity squared over n minus 1. Now, the definition we gave was for standard deviation, and then we did what? Took the square root of this, right? So we had the square root of the right side and called that standard deviation. Now, this is technically in algebra a proportion. What do I do with proportions? Cross multiply, right? And so I can get the following, that the summation of the y minus y bar quantity squared is n minus 1 times s squared sub y. That was just a cross product, because 1 times that summation is the summation. Do we agree? And I'm going to give a new name to that. I'm going to call it TSS, total sums of squares. Would you be kind enough now to take n minus 1, which is 5, agreed? And I'm going to multiply it by what? S squared sub y, so I have 5 times 45 roughly. So I'm going to get roughly 225 something. It's going to be larger than that, but roughly in the 225 area. What do you get? Just multiply. 226.9. Thank you. 226.91. Okay? That is my TSS. Now, ideally, we might want to do what? Go 4 digits. Would you be kind enough, Daniel, to give me the next 2 after the 9-1? 9075. Thank you. And again, I'm just, there's a little bit of disingenuous behavior on my part because I took my y hats to the hundredths, and then I'm taking the squares of the differences to the 10,000ths. So I'm introducing a little bit more precision than is justified. But I want to protect some round off here, and that's the only reason for it. I'm considering these last 2 digits buffer digits. Okay? Now, there's a very important concept in bivariate data analysis, and it is that I can partition this TSS into 2 things. I'm going to partition TSS into something called SSR plus SSE. Now, we had SSE yesterday. Just a reminder that if we come back to the document cam, as soon as I try to get things structured there we go. Let's go to the document cam. There's your summation of the E squareds. That is SSE, sums of the squares of errors. So up here, I'm going to write, let's put that back on the screen so I can see it just for a moment, Jennifer. SSE, which was the summation of the y minus the y hats quantity squared, which is equal to 84.2249. Okay. So I've taken care of TSS and SSE. I've not made clear what SSR is. But if you think of your algebra class, and you know SSE and you know TSS, you could subtract and get SSR. Agreed? So SSR, if we look at that, is going to be TSS minus SSE, even if you don't know what SSR is. So that means I'm going to take this 226.9075 and subtract this 84.2249 and get SSR. So down here, I'm going to write that I have 226.9075 minus 84.2249. And I'd like to know my value for SSR, and it's going to be 142.68, 2 more digits, 26. Thank you. Now, you may not appreciate, I know you won't appreciate, what we've done here, but I am about 30 seconds from where I wanted to be at the time we are right now, which I'm very pleased about. I wanted a half hour, roughly, for the lab presentation. Now, what is SSR? It's the sums of squares of regression. SSR, and I'm just going to put it up here, is the summation of the y hat minus the y bar quantity squared. Now, just for your information, note, this is worth noting, the ordered pair x bar, y bar is on this line of least squares. Is on line of least squares. We said yesterday that's what we call the regression line. Least squares. So what I am saying is that there is a natural variability because those points are on the line. If it was a perfect model, every point on the line, then I would have an SSR. And SSE would be 0. Listen to that one more time. If every point was on the line, and what I'm going to have to ask you to do, Jennifer, is slide over to pick up the TSS for me, please. There. If every point is on the line, SSE is 0. And TSS is equal to SSR. One more time. If all the points are on the line, SSE is 0, SSR is equal to TSS, and so I want to consider this ratio, SSR to TSS. I want to consider that ratio. If SSE is 0, this becomes 1. That's the maximum it can be. 100%. So we're going to call that r squared. Now if, and just tweak a little bit more, thank you. If my points are way off the line, what's going to happen to SSR if the points aren't very close to the line? My SSE gets larger, so SSR gets smaller, correct? And so if this gets smaller and smaller, the further the points are from the line. So this becomes the percent of the variability of y explained by my linear model. So r squared is the percent of the variability of y explained by the linear model, and we call it the coefficient of determination. So if we have r squared, we could get r by taking the square root. But let's get r squared first. You now have SSR, so we are saying that r squared is equal to 142.6826 divided by what? TSS, which was 226.9075, agreed? What is that as a percent? I'm waiting. I spend a lot of time waiting. 0.6286, roughly 63%, agreed? 63% of our variability in life expectancy for a female is explained by our linear model. That's how we measure how good things are. This isn't considered too bad. If it was only 50%, I wouldn't be happy. If it was 98%, I'd be euphoric. At 63%, okay. But I want R. R is the square root of R squared. Now, technically, we would say the principal root, correct? But you have to be careful here because we want to determine if the association is positive or negative. If your slope is negative, R will be negative. If your slope is positive, R will be positive. So in this case, we're going to use a negative. So what is the square root of 0.6286? And I should have put a minus sign in front. Minus 0.7929. Do we agree? So we have a name for this. Open your textbook, please, and look at the title for Chapter 4. I'm going to come back center. Is that set up so I can, Jennifer? And I can't see you, so just wave. Okay. So I'm going to come back center for a moment. I'm going to ask you to find what we're talking about. Did we adjust the color at all?
No.
Because now I look.
Yeah, A is not working with color. There, now you got color. Isn't that weird? It's very odd. One is not, it's not being cool.
Okay.
Being focused, or
So I can either have a sunburn
yeah.
or look like a ghost of departed past. Okay, so Chapter 4. What's the key word you're seeing there? We already talked about scatter plots. Correlation. None of what I've done on the board in the last 35 minutes is in your book. Okay? But it is the best I can do to share with you what correlation means. So that correlation you see in Chapter 4, we talk about scatter plots and correlation. So I'm going to come back over here and looking like, okay. And what are you doing back there with switches?
All I'm doing is going to camera 2 on A, and then when you go in black and white, I go to 2 and go to camera A.
Okay, you're having fun back there, I can tell. Okay. More buttons, all the better. This is the correlation coefficient. And without R squared, it doesn't mean much of anything. The correlation coefficient at negative 0.7929, it can be at max either way, positive 1 or negative 1. But unless you know what R squared represents, this doesn't tell you much. Now let's see if we can get that same value out of the calculator and hope we didn't screw it up. So we're going to go to the calculator, and at the moment, let's go back to the document cam for a moment. That gives Jennifer an opportunity to play with her buttons. And like button, who has the button? I'm looking now at the calculator and I'm hunting for a key that just might give me something called R. Okay, do you see? I've sort of forced your attention to a certain part of the screen. Do you see anything with a little r? Right above the division key? So if I do RCLR, I should get what? Just maybe something that agrees with what we've done. Now, I'm going to turn on the calculator and hit RCL division key. And I get 7863. Okay, so I'm getting a 7863. R at negative 0.7863. I'm going to round that off to what? Hundredths, which is the game I was playing. Everything to hundredths. We have buffer digits. So round this off now to the nearest hundredth. Round this off to the nearest hundredth. And do we agree? Yes. Now, how would I have managed to get more digits to agree? I would have taken my e's to the thousandths position. or the 10,000th position. Now, what I've just done here is worth 10 points on the exam, coming up a week from this Thursday. Now, it took me a lot of time to write out a lot of things and wait for you. It took me about 30 minutes to do what I'm going to give you 12 minutes to do. Practice it. I will ignore your comment, Juan. Something about unfairness, but remember, we had delay after delay after delay, waiting for you to nod and agree with values, and again, I will facilitate this by possibly giving you the y-hats. Okay, and I might even give you the e's, depending on how complicated the problem is, but with about 6 data points. Not unusual. Now think for a moment, if r is just 0.7, what is r squared? 49%, right? So if r is 0.7, you square r, you get 0.49, 49%. That's less than half of the variability explained by your model. Let's say that your r is 0.5. What's r squared? 25%. So what would be considered a strong relationship? Something that's going to give you about, at minimum, 50%. So you're going to find in the lab that I ask you to do, you're going to find that I argue a 0.7 or higher for R would be considered fairly strong. Anything under 0.7 weak. In the argument, square R. If you're only explaining 25%, are you going to be very euphoric? No. And if you're explaining like 90%, you're going to be pretty darn happy. So if you look at an R value, and I, again, am going to go back and center here. Let's come back to the document cam just for a moment. Remember, this was our R. So the question, do I feel good about that? Well, I feel good to the extent that R squared is explaining, as we saw, roughly 63% of my variability. If I have a strong relationship, the value I predict I feel good about. If I have a weak relationship, I don't feel so good about it. Now, last question before we talk about the lab. Yesterday, I used this to, I believe, predict a life expectancy for one country, and I think it was Canada I used. Would you be willing to use this model to predict Niger? Give me an argument.
No, because our value for Africa was really low. It wasn't the usual.
Oh, okay, that was a different answer than I expected. What Sean said is our value for Africa was not representative, and so we probably haven't represented Africa well. Remember, we had Algeria, and we had a value that would be more typical of, say, South America than Africa. What I was hoping that I would hear, and that's not a bad answer, what I was hoping I would hear is that Niger or Niger has a birth rate up around 40-something, correct? But what were the values of X we had for the scatter plot? They were between, and let's just take a moment to look at what those X's were between. Okay, coming back to that, it's not all that neat, but we went from 10 to what? The low 20s. The range there is about 10. Rule of thumb as we come off there. You're allowed, and I say that loosely, you're limited, maybe is a better way of saying it, to values that exceed Rx, either way, by about 20% of the range. The range was 10, 20% is 2. So that means I would have maybe been willing to use this to estimate life expectancy for birth rates as low as 8 and as high as 22 or 23. If I go to Niger, which is 40-something, what is the birth rate for Niger? Anybody pick that up quickly? Or Linda, you have it handy there, Niger. However you have yours sorted.
No, not this one.
Okay, Niger is what?
Birth rate
Is 49.62.
4962. Let's just enter that into the calculator. So I'm going to the calculator now, and I'm going to enter 4962, you said?
Yes.
Enter that, and then I'm going to go to the gold key and y primed. I'm estimating that in Niger you're going to live as a woman, life expectancy at 47.6. Erlinda, while you're looking, what is the life expectancy for a woman in Niger? We just estimated 47.6.
It's 44.26.
We didn't do too bad then. At 44.26, we're only underestimating or overestimating by 3. I expected it to be much worse than that. So we didn't do too shabby. But do you have any confidence in that value? And the answer is no, because you exceeded the range of your X values by a lot. That came out much better than I thought it would. I am surprised. Niger is up to 42 for life expectancy for female. 44. Okay, yeah, 44. Let's try Swaziland. What's Swaziland's life expectancy for female first? Okay.
No.
S-W-A-Z-I, Swaziland.
Oh.
Waiting. Bum, 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 bum. Need
Okay.
music.
What is it? Life expectancy?
Expectancy female for Swaziland.
32.3.
Okay, so we're estimating we'd have 32 for Swaziland. I think the HIV rate there is outlandish. Now, what is the birth rate for Swaziland?
26.6.
26.6. Now hit gold, Y primed. Okay, this is more like it. Swaziland, 26 for its birth rate. Okay, and we would estimate what? 68 for your life expectancy female, and they're going to live to 32. You're going to be really surprised when you don't make it. There's a certain kind of sarcasm there, irony. If you live until 32 and die, you don't know you didn't make it till 68, but you expect to live more than twice as long as reality is. That's a kick in the pants. Is the model good? Not for Swaziland. Ridiculously bad. Even though what? 26 looks like it's within our range nearly, because we said we'd go up to 20, go up to 22, 23. We just went out 3 and have a terrible estimate, and it comes back to Sean's comment. Algeria was not representative. That slope should have been much steeper than what we had. Now remember, I asked you to participate just by finding a country on a page, and we, to some extent, tried to avoid certain biases, and then we took the last 2 that were remaining on the last page. Now that, again, is 1-letter grade on the test. I gave you a set of formulas. In those formulas, we can generate a value from R using the calculus formulas rather than this definition for R squared. That's what we'll look at tomorrow. Now, enough said there. Okay, I need now to switch the focus of both the camera and the computer, and I need to get a stat graphics window coming up here. Okay, let's switch to the computer. There's stat graphics coming up. I increase the size of the spreadsheet, and then I move the computer over, try to get to where I can do something here, and I'm going up to the left-hand corner, and we're going to open a file. So the file I want to open is World Factbook 2008. This is, I hope, getting redundant for you. There's Open the Data file. I'm not going to belabor this too much. I want to go quickly to get this open. You're all able to do this. I'm now looking at my spreadsheet with Afghanistan, and I'm going to compare, not describe, but I'm going to compare 2 samples this time. So I want in essence, I want the life expectancy female and life expectancy male, so I go to 2 sample comparison. That's the key. From there on, it's a no-brainer. So we got the first step. It's the critical one. Open World Factbook 2008, go to compare, to sample comparisons. If you can do those 2 steps and make a left click and now identify the 2 variables you want. And the 2 variables I want are what? LEF and LEM. So I'm going to double click an LEF, and what you're going to see as I come across, I should have picked that up at the top. I'll show it to you. There's the first one. And then I'm going to LEM, and I have to click Sample 2. Now notice there is a little default here that says I have my data in 2 separate columns, and indeed I do. Now later on we're going to do data and code. But I do OK, and there you're done. Now that's not too bad considering what we've been going through. Zoom out and increase the size of this. And I'm sorry, I've got to take care of this. Okay, I don't like what I'm seeing there, so I'm selecting that. I'm going to go to graphics options. It'll take me just a moment. I'm going to here, I'm going to colors, I'm going to go to yellow. I'm going to say OK, apply, and say OK. Now I'm happy. Now as we look at that, first observation, lots of little boxes. Yes? Those little boxes mean suspicious points. Not as many little boxes. Not as many suspicious points. LEF on top, LEM down here. That's what we talked about, correct? Now, note the relative position of the mean marker. What does it tell us? Loudly enough that I can hear you. Louder.
Skewed to the left.
Skewed to the left. Thank you. Get you a megaphone. Okay? Skewed to the left. Why? The mean is to the left of the median. Now, does the length of the whiskers support that? That's a tough call. But why is it a tough call? Well, I guess not as tough. I was thinking of comparing these two. Now, the problem here is the whisker in the simple one goes up to the last point. This is the effect of fences being shown. Again, the left whisker is longer than the right whisker. That's a no-brainer. I will concur. One comment here, just you're going to be held responsible for whether or not I can see that mean marker. If you click on that mean marker and then right-click and go to graphics options, I can make that point size larger. Okay, so I can increase the size of the point, go up about here. Then in the point thickness, I'm going to increase that because I want to be able to see it. So I'm going to say OK, and notice how much bigger, brighter, and easier it is to see. If I can't see your mean markers, I will take probably a half point off. Now, your difficulty is going to be to identify where these values are. You have to title this appropriately. You have one page of output here from this box plot. Title it appropriately. But how are we going to find what countries are represented? The key here is something I like about stat graphics. It's called a hot link. So let's go to the camera. See this value down here at the very end? And I have a hunch that's Swaziland. Notice where I'm locating. I could locate it here or here. So I'm just going to locate it. Now look what happens. Do you see the yellow showing maybe? It highlights it. Now what I'm going to do is go up to the top, and I'm going to go to the window, and then I'm going to come down, and I'm going to go to World Factbook 2008. So I click that. What I'm going to see as I zoom out is I have highlighted that country. And my argument was that it was Swaziland. Indeed it is. Okay? Exactly what we thought. You have a life expectancy at 32 years. Folks, that's unusually low. And by the way, the predictions are, the way things are going in the world, that we may drop below 30 in certain parts of Africa. You realize the last time a life expectancy was that bad? What century? Louder. I can't hear you. What was the number? I don't know, I now get.
1100?
When?
1100?
About 11 to 1200, right in there, the Dark Ages. Okay, where they depict that sometimes when you see movies back in the days of Camelot and so on, and contrast that to just horrible conditions. We haven't been there for centuries, and we're heading in that direction in certain parts of the world. That is, to me, frightening in terms of what it says about our modern world. Not so modern at times. Modeling would be better. Now, what is my problem as I now go back to the camera? I've got this file. How do I get back to my analysis? Go back to Window again, and then just drop down, and at the bottom I'll find my two sample comparison. So just go back there, and I've got what I highlighted. Now, do you understand the problem I'm going to have separating some of these little boxes out? Because they overlap. How can I do that? Well, you aren't going to print this, but what you'll do is come down to here. Now, notice I'm like between what? Maybe 40, say, well, if I look a little bit more to the left, there's 31, right? So maybe if I went from about 35 to 41 for my scale, so I'm going to left-click here, right-click, and I'm going to Graphics Options. I'll just tell you where I'm going. And I'm going to look at my scale, and I'm going to go 35 to 40. So up here, I go from 35 down here to 40, and I'm going to do it by 1, and then say OK. Now look what I've done with my points. I've spread them out, correct? And now I can do what? Zing in on each one and do exactly what I just did. Highlight, as we come off there now, highlight that and record the countries involved. That's how you play the game. Your biggest difficulty here will be getting those countries. I'd like you to practice doing that with the scaling. Now, Clorinda will give you a way of more efficiently doing it, but I'll let her explain it. That's a good incentive to go out to the lab on Sierra Hall 221. Okay, we managed to do what I wanted to do in covering how to do the lab. And Jennifer, we started...